Good afternoon, Web Summit. I see that they've put on really loud rain so that I can try and compete, but luckily I'll just yell over the top of it. So yesterday, if you came to my talk, I spoke about, what did I speak about yesterday? What we spoke about was scaling startups. And in that talk, I talked about innovation tickets. So not choosing bleeding edge technology when you're building a startup. And I couldn't remember the guy's name. So the guy's name is Dan McKinley. You can go to his website, mcfunley.com, and you can read the post called Why to Choose Boring Technology. And it will have the background in the why I was talking about innovation tickets yesterday. I felt really bad when I got off stage. I tweeted Dan to make it right so that he knew that I'd done it. So if you do want to read that post, go over to mcfunley.com and you can read about why you should choose boring technology. So today, we're going to watch The Fifth Element instead of looking at slides. That would be really much more fun probably than talking about transaction processing. So this is from a movie called The Fifth Element, done by Luc Besson. And our hero opens the door one morning and there's a guy standing there with a gun who says, "Give me the cash." And when you're talking about a startup who's about to take your money and you haven't processed people's money before, you haven't integrated with a card gateway, it is kind of like someone standing at your door just ripping the cash off you. And so hopefully we can make that a better experience. But also as startups, we need to make revenue to survive. So we do need to take cash. But as Breaking Bad found out, when you start getting cash, all of your problems don't go away. In fact, you get a whole new set of problems, like when all of your cash falls in a swimming pool, for instance. Hopefully that won't happen because we're dealing with online transactions. But there is a famous saying, which is more money, more problems. And as you start taking people's cash, you're going to have to start thinking about regulation, about where people's data is stored. You're going to have to start thinking about integrating with payment providers like PayPal and Stripe and the other popular ones. This is also a developer workshop. So one thing I really dislike is when I go to other talks and they tease me and tease me and tease me about a demo, tell me they're going to do one, then they do it, then they don't provide me the code, or they give it to me on a slide. So we're already 19 workshops in. There's only 2 left. We're on the last day of Web Summit. So if you want the code, you can just have it now. You can just go to this bit.ly link and take the code and walk out if you want. You don't have to listen to me for the next 38 minutes. If you want to understand what you're going to download and actually load into your AWS account, I will explain that after you've taken the code. But you can just take it now if you want to. So what that will open up is a PCI compliance QuickStart on Amazon. You can deploy it into your account and it will build you an environment that is PCI compliant from the start with resiliency built in. A couple of caveats. If you're already using AWS or you have an account, don't click that button in an account you already have. It is built as a very opinionated framework for a new account. If you already have workloads in there, it will try and apply all the PCI compliance controls to them and probably mangle what you currently have in there. So the best way is to go and sign up for another free account on a trial period and then click that to see what it does. Don't do it in something you've already got running in production. So we want to take people's money. Unlike Breaking Bad, we can't get bags of cash and store them in a storage locker. So we need to actually go and take people's credit card. And credit cards have a whole bunch of data that's very important. And depending on where you are, most people around the world now have the chip, they have the PIN, and they have a CVV on the back of a card. And that's information that you will need in your startup. But as soon as you start to try and store that, you come across this table. And as soon as you want to save some of this information, you will get slammed with one of these, which is basically the PCI DSS compliance standard for storing credit card data. And it tells you what you can and can't do with it. Now, you can outsource this problem. So if you're a small startup and you want someone else to take payments for you, then that's fine. They sort of deal with most of this. You still have to deal with a little bit of it. But this basically tells you what things you can and can't do with that data. And at some point, even if you're outsourcing it, you have to get it from your mobile device, from your web browser, on your servers, to the third party. So these are our friendly neighborhood cops as far as payments go. PCI Standards Council. So it's international, it applies everywhere. Anytime you use a MasterCard or a Visa card, you'll come into contact with these people. And depending on what your business does, if you're a business as a service or a SaaS platform, or you're taking payments on other people's behalf where you're doing multi-tenancy, you'll actually have a different set of regulations that are even stricter that apply to you, called service provider restrictions. So there's a bunch of different ones that might apply depending on where you are in your startup. I can't individually question all of you in here, the 200 of you sitting here. So if you're doing hardware manufacturing, so you're building the next, I don't know, payment swipe thing, you'll need to do the PIN. The red one in the middle is for service providers and application. You wouldn't normally necessarily need to do that unless you're going to build credit card issuing and a few other things. And then the one at the end. So AWS, for instance, is a PCI DSS level 1 certified. So we're basically at the end, we can give you an environment that is PCI, but you still own the responsibility. And so the data standard will apply differently depending on how you're going to deal with these credit cards. These are the 12 requirements that actually make up that data table I showed you before. So this is actually what you're trying to comply with. Of course, if you go and download the actual spec, it's hundreds of pages and has lawyer speak in there, but that's actually what the 12 kind of list of things are that you are supposed to be doing. And there's one in particular, this one, that causes most of the problems in any kind of implementation of payment services that I've seen. So PCI DSS is currently at 4.1, and it specifically talks about encrypting the data. How many people in their current business or in their startup now encrypt the data all the way through to the database? 2 hands. Like a forensic security place or something, maybe? What business are you in that you do it? And so most people don't actually take that much precaution. They normally terminate SSL at a CDN or a load balancer, and then they forget about it. To kind of explain it a little bit better, here's an actual transaction going through your services. So in the old standard of DSS, you needed to actually do SSL all the way through. You can't actually drop the handshake in your private environments. Luckily, they have changed that. They have now said that it's only over untrusted networks. So if you trust the cloud network for putting production on, if you trust your own internal network, or you're living on one server under your desk and you basically trust it because you've got one server, then you now only have to go to here. So if you might have a CDN in front, a content delivery network, so you'd terminate there, you would then re-terminate here, and then you don't have to worry about this. And the reason you don't really want to do this, even though it sounds awesome to have all that security and to sell to your customers, is because SSL is really expensive. It actually takes a lot of compute power to terminate and do the asymmetric and the symmetric cryptography. It also makes it more complex to debug things because you can't Wireshark your data. You can't man in the middle yourself to see what you're doing when you're building your APIs. And if you don't do it, it will increase your audit by what they call a QSA. So does anyone in here have to get PCI regulated at the moment or is based on their startup? So what you need to do when you go and build it is you'll get this person called a quality something or other assurance. It's basically like an auditor that is accredited by PCI to come in and audit your infrastructure. All right, so now we know why we're building stuff. Let's go and build something. If we're going to do that in the cloud, there's one really important thing you have to understand. We are the orange on the right-hand side, and we provide the security of the cloud. We make sure people don't drive trucks into the data center, and we make sure that people aren't moving servers and they don't know where your hard drives are. We toughen the edge so you get DDoSed and different things like that. But you're responsible for the security in the cloud. I don't know what your data is. I don't know if it's your notes from your Mac that are completely irrelevant about shopping lists, or whether it's actually millions of rows of customer data. And so there's no way for me to tell you how to secure your data. I can give you the tools, but I can't do it for you. This picture is better described, the first picture is better described in this. Here's the things that we do. We take care of the security of the cloud. You have to take care of the security in the cloud. So your customer data remains your responsibility. Where you put it, what region you put it in, if you've got to comply with GDPR, if you need to do something like put it into Germany where you have to have data centers in the country, those are decisions for you to decide. Once you put data in a region, we will never move it. We give you tools to move it if you want, but we're not going to move it cross-country, so you don't have data sovereignty issues. So yesterday in the crowd, I polled how many people were thinking about doing microservices or are doing them. How many are doing them in this crowd? OK, cool. Let's talk about building a microservice payment system. So microservices, if you don't know, who doesn't know what microservices are? I'm not sure anyone put their hand up if I asked the question. So there's kind of a golden rule. Basically, start with a monolith, break it down into business domains and service components, and then as you start, basically you shouldn't do it on scale. You should do it on the fact that you can't change things fast enough for the business anymore, so you start pulling the thing apart. There's two services I'm going to talk about. You don't have to build your payment system in these. They're just here to demonstrate how to do some of this. So the first one is Lambda Functions. Lambda is a serverless technology. It's where you basically upload your code and the cloud runs it for you, or any of the PaaSes. You can run them for up to 15 minutes. They have all different types of language support, and they can be event triggered. So for instance, if someone wants to add a credit card or remove a credit card or make a payment, we can grab those events from different event sources and do something with it, execute code. And you only pay in 100 millisecond intervals. So you're not paying for a server sitting around when you're not doing something. But Lambda functions are stateless. They're like most microservices. They don't hold any state. And so if I wanted to do a payment, but something happens like the credit card is invalid or the third party doesn't hold it, I have no way of grabbing that state and putting it somewhere else. I can't pass it to another Lambda function. So you need some kind of orchestrator. So in Amazon speak, we have one called step functions, and it is a state orchestrator for servers, for serverless, for anything really. We even have human tasks that you can set to have 300 a year worth of waiting on, so that you can push things through different through different states. And so if we take these two and we think about making payments, you should always design a system for where you're going to be in, say, a year's time. Don't try and do it in 5 years' time, because you won't know, so that you don't build something that you're going to have to change and throw away and build tech debt. So if we think about a payment system in its basic form, we need to execute payments, we need to register customers, we need to register cards, we need to think about what happens when things break and they need to back off. And so I could do this with servers, I could do it with a monolith. It's just easier to fit into your head if you think about individual functions. So each of the little squiggles are Lambda functions. That's the icon for it. And then there's a step function in the middle orchestrating the different states. So what that looks like once you pull it out of the domains in code is something like this. So you are now mapping exactly those boxes I have on the original slide into the actual API that you need to build. And so from here, then we can start to talk about rollback. We can start to talk about whether it's idempotent or it's not. And we can map those into something like a Java class, where we can then use that for our payment system. So for instance, if we look at execute, we can actually drill into what's going on inside the execute payment. And really, there's no wiring in here. I'm not mocking something into one of the third-party payment providers. What we're really doing is basically breaking out the domains to figure out how to build the API. And that will work if you're a customer-facing business, i.e. you're not about to do multi-tenanted SaaS, you're not hosting a whole bunch of other customers, you can build an opinionated API and deal with their credit card data. But the issue is if you're storing it yourself, and you're a business-to-business or a SaaS, then you have another problem, which is as soon as you store that credit card data, you get the first table that we looked at, the first slide, which is now you're responsible for a whole bunch of things. And so what you need to do is basically build a segmented cardholder environment. You should never try and build anything that's regulated into your normal system. The issue for most startups is they've built a monolith. So as soon as they start storing the card data, everything becomes regulated and becomes in scope for audit. So the reasons you want to do this is you isolate the hard bits, so the things that you can't change fast, that you might have to lose customer data over if you're losing credit card data or storing it. And you want to reduce the scope of your audit, so they only ever have to look at the systems that they're dealing with payments. So if you look at something like a bank, and banks don't really apply to startups, but they apply for the fact that in 5 years' time, if you're successful and you're in growth stage and you have a whole bunch of different systems and you'll probably have a whole bunch of different deployments, you're going to have systems that look something like this, where you've got customer and you've got data systems and you've got business analytics systems and offline data processing. And when you start, everything is going to be in scope. And if you're hosting multiple customers, you basically have to show that all of these different components that are now in that one box, which is your PCI audit, aren't actually cross-pollinating the data. And so what we want to do is we want to segment that out. We only ever want the payment stuff, how we store the payments, how we deal with the third party to be in one system. And one system that's completely separate apart from API calls to another system, so that you're not increasing your regulated domain. And if you start to get that far, you've built a nice API, you've deployed it somewhere, you're starting to take people's transactions, you're going to enter a new stage of pain, which is everyone who deals with your system isn't necessarily a good actor. If there's a way for someone to game your system, to make payments and then do a chargeback and get the money back, they'll find it. I used to work in a business where we had both retail stores and we had credit online transactions. And so what these people would do is they would get a whole bunch of registered credit cards or off the internet. They would go and register them as online credit cards so that they could do online payments at about 11 o'clock at night. And the retail places I used to work at used to be mostly in bars, so you could go and buy things over the bar. And in a bar, you will have some young person behind the bar who doesn't really care much about money laundering and fraud. So they would register all these credit cards, and then straight after midnight, when a new day rolls over, because there's transaction limits per day, they would get all these people to run into bars and withdraw cash from their account after making these transactions and registering the credit cards 1 hour before. No one behind the bar thought anything of it because everyone was withdrawing cash. And so in the morning, we would wake up and we would have 1,100 transactions for a couple of $1,000s each, and the cash has just disappeared and basically walked out. Now, you don't have that problem in startup land as long as you're not doing anything in retail, but it just shows that any kind of system that you have will be gamed by people. And so we have to think about fraud. We have to think about the ways that we're going to stop fraud. Even if you're using a third party, the third party is only ever going to verify that the credit card is valid, that the people have money. There's whole bunches of other ways for people to get reimbursements from you, start chargeback schemes where they're constantly charging you back so that people start blacklisting your APIs. And so you have to think about enforcement and containment. So I'll talk through an Amazon example, and hopefully you can map that to your business. So when a person first creates an AWS account, there'll be a day before they actually launch their first server. And their first billing is 30 days later because we bill monthly. So if you're in a startup and you're not billing straight away for a subscription, you're billing monthly, or you've got a free trial, there's a whole bunch of days where you don't really know what that person's going to do with your system. And so for us, that causes us to do a bunch of different actions in that first 30 days. For instance, if you go and open a new AWS account, you can't just go and get the biggest graphics instance to start Bitcoin mining 1 minute later. every single account starts with a 0 limit. There'll be other things in your startup like that where if you're doing recurring billing or where people can consume more than just a $25 a month SaaS business, you'll need to start thinking about restricting new accounts. Start building a history of their data. So you can do that in lots of different ways. You can pay third parties to do it. You can do really simple stuff like look at the digital fingerprint. Why is this person always registering credit cards from a different country but their address says they're in another country? If you deal with the really large online providers, you'll notice that if you try and use, I've moved around the world a lot, if I try and use my credit card from different countries, I get blacklisted basically and I have to ring them up and try and get unlocked. So you can just do simple geo checks. Then you can get more advanced. You can start dropping session cookies. You can start doing things like detecting VPNs, detecting latency for the person. And you can add those up to basically make a fraud score and a containment score. So these are the services that we use internally at Amazon to build a fraud service. You don't have to build anything this complicated. You can just start out by basically restricting your accounts. The other thing is once you build an environment, especially if you're doing non-serverless where you've got servers around, there's these wonderful things called CVEs. So things like Heartbleed back a few years ago, open SSL vulnerabilities when you're doing TLS. And so it's really hard as a startup to figure out how to keep in compliance. So this is a tool called Inspector. It's one of the Amazon ones, but there's plenty of other ones. There's a good third-party one called Qualys where you can scan systems. And there's a list called the CIS benchmark. It's basically the current active vulnerabilities around that you should protect against. And what this tool does is scan everything that you have in your account for these vulnerabilities and gives you a report. So you can go, okay, well, I'm wondering if I'm affected by this thing I just saw in Hacker News. You can basically do this scan and it will tell you if you are across Ubuntu, CentOS, Amazon Linux, like a whole Windows, a whole bunch of different operating systems. If you're operating in Amazon, we have a nice tool called Trusted Advisor. It will tell you how much you're spending, whether someone's gone rogue and they're auto-scaling your fleet or something. It also will tell you that you have public S3 buckets. So there's been lots written about public S3 buckets. By default, S3, which is a storage service, is completely private, but you can turn it to be public. And the reason that people turn it to be public is because they generally want to host a website on it. The unfortunate side effect is that some people turn it public because they can't figure out the security model or they misread the security model, meaning that when you have credit cards, your customer accounts, a MySQL backup dump that happened to a customer recently, then those get exposed to the internet. There are bad actors on the internet scanning S3 buckets thousands of times a day looking for these types of information. So something like Trusted Advisor will instantly tell you you have a public S3 bucket. So if you do go and click that PCI compliance QuickStart, and then you go and look in this tool, you'll see a whole bunch of different security actions that come out of it. And once you start to get to the 10 plus people, you start to get out of the trusted co-founders and the development, you kind of need to figure out what's going on in your own environment. So you need to be able to audit. Why did Bob just give someone admin permissions? Why does Bob's girlfriend keep registering credit cards all the time in my environment and doing chargebacks? And so you need tools that will allow you to see what people are actually doing inside your environment. And as a startup, security is generally the last thing that you index on because you're trying to get product out to market. So it's not until you lose some data or a bad actor basically shuts down your startup. And there's been pretty famous cases of startups that have been shut down by people taking away their admin keys or using their phone as like a two-factor authentication and leaving the company and no one can access anything anymore. So it's really important that you think about who has access once you start to scale. We talked yesterday in the internet scaling about logging. Creating one type of log won't really help you when you're starting to do payments and you're starting to do larger applications. You need to think about what the purpose of keeping each of them are. Storage is cheap these days, but you also don't want to trawl through 10 terabytes of logs to find something that's going on. If you build in forward containment, there's catching it as it happens, but there's also, at the end of each day, I need to add up all the scores of my customers to see what they're doing. And so thinking about the different types of logs that you generate, and there's use cases on the end there, and how you're actually going to keep them and look at them is a really important thing to do. It will also mean that you'll transition into that event-driven style architecture where you'll start using things like Kafka, and you'll start doing automatic actions based on those events that you're generating. So when I was working in customer land a few years ago, we had an issue where we thought that our sign-ups in our startup were massive. And we were super happy because our growth had just gone hockey stick. And we started to do some logging, and we started to do a bit of security analysis because we had some other bad actors on the website. And as we started to do that, and then started to look at things like browser agents, started to look at where people were coming from, what their names were, and starting to aggregate some of that data, we actually realized that about 60% of our new accounts were completely fraudulent. They were basically being built by bots. And the reason they were doing it is because we used to have real-time pricing information, and if you were not logged in, then the real-time pricing information was delayed. And so we wouldn't give you the most up-to-date prices. And so they were creating thousands of accounts to basically get real-time pricing updates for different markets before we would basically blacklist them. And then they would sell those to third parties. So instead of paying for our subscription, they would sell them to our competition. And the only way we could really figure that out is if we actually did proper in-depth logging and event analysis. So if you have a huge hockey stick growth spike and it's not because you've had a stand at Web Summit, you might want to start to ask why you've got all these new accounts from particular regions around the world. So this is the PCI DSS QuickStart that I talked about at the start. It's a CloudFormation template. Unfortunately, that's not very vendor agnostic, but you can read through what it does. It will actually create this environment for you. So it is a highly available, regulated environment that you can build PCI workloads in. One of the reasons why you might want to do this if you're a FinTech is a lot of FinTechs aren't targeting end customers. They're targeting banks, and they're targeting providing services back to the banks. And the banks won't necessarily care about PCI, but they'll care about a whole bunch of other governance that you'll have to go through if you're trying to sell to a financial organization. So startups that I talk to kind of do all of this stuff after they're trying to get that first bank. And it takes them ages to remediate everything and commit back to the bank and fill out the lines and pages of paperwork to say that you're now a trusted supplier to someone like a financial services organization. So by clicking this button, you can start it the right way and say that you're already X amount of way through the scope of PCI, you're already ISO 27001 compliant. And so there's a whole bunch of compliant things you won't have to worry about if you're a SaaS startup who wants to sell to other financial companies. I'll give you the link again in case you didn't get it before when I stuck it up. So you can basically go and click this and it will build that for you. Like I said, don't do it in an account that already has deployed infrastructure in there, because it will tighten the security of everything and probably break it. If you are going to integrate with a third party like Stripe or PayPal, how many people have done that or are doing it currently for their startup? How are all the rest of you making money? Are you building your own? Are you not taking any money? Are you an ads business? You came to a transaction processing and payments talk, so I'm a little bit curious about how you're actually taking that money. Are you a B2B, so you're basically signing contracts offline? How many people are doing B2B and signing contracts offline? That's 2 out of the crowd, so there's still 100 of you. I don't know what you do. Interesting. Is it because you're on the blockchain? Is it because I'm too old? I was born in the 70s and I don't understand the tech. Are you distributed? Do you have consensus? So as you're building out third-party systems, Stripe has some really cool tools. They have Stripe Mock. Stripe Mock will give you a complete mock of their API. I've actually started to build out the serverless architecture we looked at before, which has an opinionated way to integrate with a third party. If you're starting to use something like Stripe Mock, it doesn't have state. So there is a kind of gap at the moment where if you want to do something like register a customer and then hit it again to make sure that you can test if that customer is there and then create a plan and then make a payment, you can't actually do that currently. So you have to do a whole bunch of extra work. So if you're doing third-party integration, building out a mock suite of what their API is, and the easiest way to do that is go and grab a tool like Postman or Insomnia, create a real account, create payments, and actually record the transaction, and then just save them on your other end so that your new developers who aren't building the payment system can basically download from there. All right, second last talk. I'm going to let you go early. I'm Sean Ray. So that is processing payments. I would have loved to give you a live demo today. I'm unfortunately on a loaner laptop. That is my Twitter down the bottom. I'm actually going to post the code of building a transaction system in microservices and in the Lambda and step functions to show you how to do it. I'm going to basically run it over a couple of months and put a few billion transactions through it to see what the failure rates are for using something that is that higher order service. So if you follow me on there, I will tweet out when I've dropped the code on GitHub for you. So thanks very much. We've got about 5 minutes for questions. Does anyone have any questions? I'm still very interested in what the other 100 of you are doing to make money. Okay, thanks for your time.